Hi, welcome to the Pilot Forge. I'm Rikit, and today I'm going to talk about navigation, general navigation specifically. Now, you've heard from a lot of schools, you've heard from a lot of teachers that navigation is very difficult. Let me tell you, it is not. The subject is extensive, but on the whole, you have been navigating from one decision to another, from one place to another, and from one point in your life to another for the longest time. The only thing you need to do is to understand the parallels between the navigation that you've been conducting on a daily basis, and then just start understanding how it works with navigating in the air. Alright? I'm going to simplify it. I'm going to simplify it for you, and you can try and use it as much as you want. If you find it difficult or if you find any difficulties, let me know. Now, before we begin navigation, we need to understand a little bit about the planet we live on. Alright? The Earth we live on is a sphere. Now, this is the representation of a sphere on a flat piece of paper. In my case, it's the board. In your case, it would be a paper. Alright. Now you can see that it looks spherical, right? It's a circle. Now what happens is there are mountains somewhere, and there's deep troughs somewhere else. So you can see that the shape isn't exactly spherical or exactly circular, but it is as much or as close to a sphere as possible. You can call this a spheroid or like a sphere. Now the thing about this spheroid is that you need to understand that it spins about an axis. This axis is called the north and south axis. It is a geographically present axis. It's called the North Pole and the South Pole. Now, the North Geographic Pole and the South Geographic Pole are tilted, and when you look at the Earth from the North Pole or the South Pole, you can see that it spins. This is the reason why we also have day and night, but we can take a look at that a little later. We've taken a look at the fact that the Earth is a spheroid. We also need to realize that it is not just a spheroid, it is compressed from the top and the bottom, as in from the North and the South Pole. And therefore, it is not just a spheroid, it is an oblate spheroid. Okay. That's the sphere. For purpose of explanation, now I'm going to use the North and South Pole as the top and the bottom of the circle. Alright? North Pole, South Pole. Now this is a nice circle, but like I said, it is an oblate spheroid. That is what your Earth looks like. It is compressed from the top and the bottom. Alright? Logically speaking, if you draw a line, this line, the vertical line, NP-SP, would be shorter than the EW line. Okay? Does that make sense so far? Good. So this is our Earth, okay, compressed from the top and the bottom, so that the distance between the North Pole and South Pole is less than the distance between any 2 points on the horizontal axis. Now, what I want to bring your attention to is the North and South Pole and the axis that it runs on. All right. This is the planet. We're taking a look at the planet from the top down, which means that we will have the North Pole represented as a dot. Now, this is the North Pole. What I want to bring your attention to, or rather, what I want to call your mind towards, is the direction in which the sun rises. Does it rise in the east or the west? It rises in the east, doesn't it? But it sets in the west, and that is, it's something that you cannot actually, negate. So if the sun's rising in the east and sets in the west, what does that indicate to us? It means that the planet is rotating in such a way that if there's a place over here the sun rises here and then it sets over here. So it goes in this direction. The sun goes in that direction. But it also means that the earth is rotating this way or anti-clockwise. For now, remember this. We'll give it a little bit of definition as we figure out what directions are. Now, you've seen the anti-clockwise direction, you've seen the North Pole, okay? But now there's a little bit of an ambiguity. What's to the left and right of the North Pole? We need to find that out, right? Let's find out about directions now. Before we get deep into the directions, what I want to bring about is a little bit of an orientation again. That is our Earth. For purposes of explanation, North and South Pole will be the top and the bottom of the spheres. The tilt does exist, but in this case we are using it, or rather we are losing it for the purpose of explanation or simplicity of explanation. Now, the line joining the North and South Pole we talked about was the axis, isn't it? Now, if we were to join the lines here again, this is what it would look like. This is not just one line that joins the North and South Pole. There are many. They're called meridians, all right? They go in this way. They follow the surface of the Earth, which is why they are curved, okay? Now these meridians, they run north and south, and if you were traveling along one of these meridians, you would be traveling in either the north in that direction or the south in that direction. Okay, what you need to realize is that we don't just travel in the north and south, right? So we don't just simply travel north and south, we do travel in other directions too. So it's best that we actually, break this empty space into something we can manage. Let's introduce the equator. Now the equator runs east and west. It divides the planet into two equal parts. We'll remember that for later. But what it also does is that it introduces two new directions to us. It introduces traveling east, which is that direction, and traveling west, which is that direction. Okay. This gives us the main four directions. These are called the cardinal points. All right. But do we just travel in north and south or just in east and west? We don't. We travel in other directions too. Say for example, between north and east. Would there be a way to mention, or would there be a way to specify what direction this is? Yes, obviously. It's between north and east. Let's call it northeast. Similarly, between east and south, southeast. Southwest for between south and west, and northwest for between north and west. Okay, so these now, as you can see, between the cardinal points are called the intercardinal points. Are these the only directions we travel in? Obviously not. We travel between northeast and north also. We travel between southeast and south also. Okay, so what we can do is we can keep splitting them. Okay, but for the purpose of explanation, we just need to go 3 deep, which is any direction between north and east, the intercardinal point is northeast. Similarly, southeast, southwest and northwest, and any direction between north and northeast, that will be the sub-intercardinal points. Look at this. You've got the cardinal points, you've got the sub-cardinal points, or the intercardinal points, and then you've got the sub-intercardinal points. You know what the best thing is? This exists everywhere on this particular surface. As long as you have a meridian which points north and south, and as long as you have a line that is parallel to the equator that runs east and west, you will have the ability to split the directions into all these directions, right? For the ease of explanation, or for you to actually see it better, I'm going to erase the sub-intercardinal point so the picture looks better. All right. Now, I just spoke to you about parallel lines to the equator. They are these. They look like this. And these lines are called the parallels of latitude. Okay. All of these parallels of latitude are parallel to the equator, and at any point on any of these intersections with the meridians and the parallels of latitude, you can resolve the direction in any of these 8 or 16 directions. Okay, 8, 12, 16 directions. Now, would it not be easier if we had a device which could actually help us with it? We do have a device. It's called the compass. The north is represented by the number 000 and always measured in a clockwise direction. We then go towards east, which is measured as 090. You can see the angle here. So in that case, what would south be? 180. And therefore, west is 270. And then we come back to north, which is either 360 or 000. Now, does that not make life a little bit easier? This is the sexagesimal method of measuring direction. Now, if we were to go in this kind of a direction, what would you say would be the direction or the angular direction value for this particular thing or this arrow? Let's take it here and let's align it here. This looks like a 045, isn't it? It's halfway between 000 and 090, therefore 045. And degrees. Alright, direction is always measured in degrees. Now, do you see this? Do you see how beautifully it is laid out? Do you see how beautifully this has been laid out since time immemorial, since navigation has been conducted using stars? We have the North Pole and the South Pole. We have lines joining the North and South Pole all across the globe. And we have a line that cuts the entire globe into 2 equal parts, which is the equator, the northern hemisphere and the southern hemisphere. We have parallels of latitude parallel to the equator, which then gives us, because they cut the meridians, the latitudes and the meridians cut each other at 90 degrees, you literally have the directions placed. You have the cardinal points, you have the intercardinal points, you have the sub-intercardinal points, and all of that is represented in continuity on the compass. Life is easy, isn't it? This is the beginning of the first chapter. Let's take a look at the rest of it on another video. Okay?